Okay, this is Paul Gregg. We're continuing our backyard roller coaster math, physics, engineering STEM course. This is part 5, how to build the track. This is the basic track tie geometry. It's what they call 1.5 inch PVC conduit or pipe rails, which are 1.5 inches on the inside diameter and about 1.9 inches on the outside. And we use a 2-inch hole saw to cut the ends of the 2x4 ties. The real dimensions of a 2x4 are 1.5 inches by 3.5 inches. And so I offset this a little bit, 1/10 of an inch there, so that there's a little more material underneath the track rail, and it's a little bit stronger. Fasteners are going to go through at an angle from here or here. The fastener head needs to be where no wheels will hit it. And making the track ties is all the same gauge, the same length is really important because you don't want a fat spot in your track where the cart comes and binds on the track and stops. And so getting these tolerances as good as you can is important. So this is the basic geometry of a track tie. We've chosen 18 inches for our purposes for the gauge of the track. All the wood I use is kiln dried 2x4. And then I use the 3.5 inch deck screws, not desk screws, deck screws. You countersink them to avoid the PVC local stresses there and to help so no wheels hit the heads of the fasteners. So the PVC is countersunk. All right, making consistent track ties, a very important subject here. I like to make a jig. You can see there's the different tracks I've made. I make this jig. So on the side of the 2x4, you need to put little indentations. This is just a piece of metal with a pointy end on one side, and you hit it with a hammer and you make a dent. And that helps the center drill of your hole saw get in the right place every time. And those are exactly 18 inches apart because it's an 18-inch gauge track. So you hammer down this one, makes a little divot, hammer down that one, move it to the next one, make sure that this one is in the previously made divot that this one made, and then you hit this one again, and then you just continue down to where you have a series of divots that are 1/10 inch off the center of the 2x4 on this side, and they are exactly 18 inches apart. And then, like, you can make 5 or 6 of them out of an 8-foot 2x4, something like that. So it's very important to make these exactly the same length. I use a hole saw. I've used other methods for doing this, but I think a hole saw is nice. You get a 2-inch hole saw. I don't know if it matters what brand it is, but this is a nice one. And the cutting depth is almost half of the width of the 2x4. And so that works out nice. So basically, as I set this up, you're going to need a good drill press to make an orthogonal hole in this, make the cut on the edge of the tie normal to the length of the tie. It's very important. I get a kick out of people who would buy a 3D printer before they have a drill press, and then if they need to make a flat sheet with holes in it, they would have to 3D print it, which is just humorous to me. One of the basic first pieces of shop equipment you want to buy is a drill press, even a little one. And so what I do here is I put the 2x4 up there, out to the right. I make sure the table's level, and then I with a clamp out on the right end of this, I just level this up, and then you're going to make a really good orthogonal cut. This is you'll notice that this hole saw can only go about halfway down the hole, and down what you need to cut. And so you really got to go from one side then the other side. And so what I do is that there's a center drill inside this hole saw, and it makes a hole, but it doesn't go all the way through. And so then I have to extend that hole with just a regular drill so the hole sticks out the other side. Then I flip the whole thing over and start cutting with the hole saw from the other side in that same where this hole comes out. You turn it over and put it in there. So you can make really nice ties here. There may be a little bit of a burr where the hole saw can't get quite to the center of the 2x4. You may have to remove it with a chisel. But what you do is, what I do is I make one of these and then I mark it with stars or something. That's my master. And then every one I make, I put it edge to edge and see if they exactly meet up. And they usually do. You can get really good at this. So once you made a whole bunch of these track ties, and the track tie spacing is probably 16 to 18 inches. If it's in the dip where you have a lot of high loads, then I space them at 12 inches. I used to use more of them, and then the load per joint is less. Well, it's not much less, but it's just a good idea. If in a high load area, you put more track ties. This is conceptually how I do my frames. I don't like to put cement piers in. And once you get this together, it really is a mass of its own. You can put some spikes through these base plates into the ground if you see any movement or something like that. But this ends up being a really stiff, strong structure with the 3.5-inch deck screws. You'll notice it's what I call a 3-beam architecture. The two PVC rails and what I call a spine piece make a 3-member truss, and that is really quite stiff. So here's kind of a spine, here's a spine, here's a spine, and here's a spine. And they're put together. You have these vertical struts that come up to the ties. And then typically I would put some diagonals in there to give this some really sheer stability. So this thing, you can, if it's built right, you can walk all over this. An adult can walk all over it. It's very rigid and stiff and strong. So that's basically and a lot of this, is you need to have done some roof framing or get a good carpenter who knows how to make compound angles sometimes and stuff like that on the ends of boards, and your carpentry skills will go up if you do this well. But I'll leave that to you. Just read up on stick framing a roof and how to make those complicated angle cuts and stuff like that. But basically, look at what's online, look at my videos, look at what other people have done, and come up with a support system for your track. So basically, I make the A-frames first and kind of put them up there, put them in space, and then put the spines in, and then measure in here and cut the correct angle to tie each one of these in. So it's pretty straightforward, I think. And again, if you really want to know what the radius of a dip or a hill turned out to be, you measure a known distance across and then use this equation to calculate the radius. And you need the radius because you're going to be putting that into your analysis to see how many so what the centripetal acceleration is. So I'm not going to talk any more of that, but there's obviously a lot to do with the track. And I'll end here. This is we're going to start talking about after, when you have a geometry and you're building it, you can start to analyze it. And we'll go through this, putting your real numbers in to the analysis we did before. So I think that's it for this section. Thanks.